Hello everybody, welcome to Geography 5544 Spatial Data Analysis Lab. Before we perform the autocorrelation, then the cross correlation, now we are going to perform the spatial autocorrelation using R. And the source of data here is provided by the textbook of Shan and Griffith, Spatial Statistics and Geostatistics, written in 2003. So we need this data, the shapefiles data here. We need the Puerto Rico .gal, and then we need also the Puerto Rico SPCS.shp. So what we need is here in this folder, this directory. The first thing we need to do is to load some libraries. So for the first time, you need to install a package spdep and then call the library. I already installed the package, so what I need is just to call it. And then remember, we need also to call install and or call the library rgdal. We're already done. So second thing is to set our directory. A working directory, it's here. This is exactly this folder. So I set my working directory, set wd parentheses, and I put my directory there in quotes, and I make sure that I'm in the right spot where my data is. So now I have the Puerto Rico underscore spcs.shp. I would like to read, so read OGR to load the Puerto Rico shapefile. This is what we have here. It tells me it has 173 features, 8 fields, and the driver shapefile layer, all the information source we have here. The second is to read the Puerto Rico special neighborhood, the Puerto Rico.gal. So Puerto Rico NB neighborhood equal read.gal parentheses code Puerto Rico.gal. Ready, right? Then need to create a list object for binary type spatial weights. So you have the Puerto Rico neighborhood file, you have the style binary, and this function, as we always do, it's a good habit to have type the function nb list, and then put your cursor here. Is going to give you the arguments you need. So you have here the neighbors. This is our neighbors we created here, the pr.nb. This is what we created, and the list, the style, style we need here is binary. We are told to put the binary, so we follow the binary, and we run it. And then the second step we need to do is to compute the density of the farms in 2007. So farms density in 2007. Density is computed generally, as we know, the number of units over the area. Like you compute the density of the population, you take the number of population you have in the country or in the county, we divide by the area of the county. So almost the same idea here. You have number of farms in 2007 in Puerto Rico divided by the area of Puerto Rico. So Puerto Rico dollar number NO farms -07. No, underscore 07 divided by Puerto Rico dollar area, and it's going to give us our density of the farm. So now we are going to perform the spatial autocorrelation test. So there are two types. The autocorrelation test for the density farm using the Moran. So going to use Moran dot test, and the arguments have Moran dot dense den 07. This is density of the farm in 2007, and our spatial weights here, PR dot list, and we run, and you have the output values, you have the data, you have the weights, you have the Moran 1 statistical standard deviation. It gives us the p-value, and the alternative hypothesis greater. The sample estimate, you have the expectation, you have the variance. The second to do is to compute the autocorrelation test for density farm using the Jerry's ratio. So Jerry dot test equal, same thing, we have the density of the farms, and they have the weight, spatial weight, and you run it. Sorry. So Jerry C test under randomization. Farm data weights PR dot list W. Jerry C statistic standard deviation equal, and you have the p-value. Alternative hypothesis expectation greater than. The sample Jerry C statistic value, you have the expectation value, you have the variance value. If you want to plot the Moran scatter plot, right? Moran dot plot parenthesis farm dot then 07. This is the density of the farm in 2007. We compute it here, and the spatial weight, compute it here. The list object for binary type spatial weights, and then PCH you can change it as you want. I put 18 in the book, is was 20, I think. You can change 15 NC. First remove this, and the plot gives you something like that. So you change based on what's good or what is visible to you. And then next, if you like to plot the variogram, computing a variogram, you can also do that, but you first need to call the library gstat, and the pr.v can change the name, but knowing that that comes from the textbook. pr.v equal variogram farm density tilde 1 and a PR. PR is this. Puerto Rico, we read here. We have the farms here, density of the farms. It's all to have our PR.v or the variogram, and to fit it, PR.v.fit equal fit.variogram, PR.v here, and the variogram with all the values, the model SPH, the nugget, the seal, everything here provided. And we run again, plot parenthesis pr.v, pr.v.fit, and this is your variogram. So thank you for watching again this video, and I hope it's going to help you for your assignments. See you in class. Thanks.